The lecture that I went to was Physics of Baseball by Alan Nathan, and the two main topics that he talked about were the dynamics of the bat ball collision and the flight of the baseball. But I'm mainly going to focus on the dynamics of the bat ball collision. And all of the photos and videos that I used are from his website. In a bat ball collision, the batter is swinging and the ball is coming in towards the bat. At this point of contact, there's a very large force, but a small delta T, which is typical with collisions, and there's also a lot of energy loss. And in this next video, you'll see a slow motion video of what it looks like when when a ball collides with a hard surface. In this video, the baseball is colliding with a steel plate. Since the steel plate cannot be compressed very much, most of the kinetic energy of the baseball goes into compression of the baseball. This is a series of pictures of an infrared camera which can sense heat. If you look at the point of contact of the ball and bat, you can see that it is white, which represents heat. So the speed at which the ball leaves the collision is depending on three factors. The first one is pitch speed, which is how fast the ball is coming in. It's also dependent on the collision efficiency, which is properties of both the bat and the ball. So this is depending on the coefficient of restitution and also the weight of the bat, which affects the moment of inertia. And the third reason is bat speed, which is affected by the weight of the bat. And when I played Little League, when the pitcher was throwing hard, the coaches would always say, "Don't worry, the faster it comes in, the faster it'll go out," which is true. But what Professor Nathan talked about was that bat speed was actually way more important than pitch speed. He said that for about every mile per hour of extra of bat speed, you get about 6 feet more distance out of the ball. And for every extra mile per hour of pitch speed, you only get about 1 foot. So you can see that the bat speed is way more important to the collision than the pitch speed. So if you've ever been to a Georgia Tech baseball game and a Atlanta Braves game, one of the key differences that you'd be able to notice is that the college baseball players use aluminum bats and the Major League Baseball players use wooden bats. So the question is, which one is better? And the answer to this is actually the aluminum bats. And the reasoning for this is the trampoline effect. So when a ball comes in and collides with the wooden bat has very low compressibility. So most of the energy goes into compressing the baseball, as you saw in that clip earlier. But in an aluminum bat, when the ball collides with the aluminum bat, the bat can actually compress. So less energy goes into compressing the baseball, and thus less energy is lost in the collision. So the ball will actually travel further. In 2003, when Sammy Sosa was playing for the Chicago Cubs, he was suspended for a couple of games because during an at-bat, his bat broke and the umpire saw that there was a cork inside his bat. And cork bats are illegal in baseball. And previous to this lecture, I thought that cork bats allowed you to get more, the ball would go further. But what Professor Nathan actually talked about was that a lighter bat actually gives you less power because it affects the weight in the moment of inertia. But still illegal because the lighter bat allows you to alter the bat inside the strike zone easier so you make better contact. So now we're going to go into the physics of why Sammy Sosa's bat actually broke. So when the bat has what everyone calls a sweet spot, which is about in the middle of the barrel, which is right around here. And if you hit, it's called the sweet spot because when the ball hits that, you get very little vibration in the bat, so the ball will actually travel further. When the ball does not hit the sweet spot, so it can either hit out here or down here, a lot of the energy actually goes into vibration. So the bat has 2 nodes which do not move, which is the sweet spot and then around the middle of the handle. So when all that vibration goes around the bat, but these 2 points stay fixed, so the bat actually bows out between those 2 points. and eventually the bat cannot take that vibration anymore and just breaks. Overall, I felt that this lecture was very interesting because I'm a big baseball fan and I grew up playing baseball. So it was pretty interesting to learn some of the physics behind what actually goes on the baseball field, such as how a bat actually breaks. Because every single time I'm watching a Braves game, it seems like there's a bat breaking every game. So now I can finally understand how and why that happens.